let me remind you what we had started to talk about. The class is organized into three fairly specific topics, the first of which is extrasolar planets, planets around stars other than the sun, exoplanets so-called. That's our topic. And one of the things that I pointed out last time is that, surprisingly enough, until 10 years ago, none of these were known. And it's only a very recent development that there's any actual evidence that these things exist. And so one question you might ask is, why are these things so hard to find? The science fiction folks seem to have no trouble. They just sort of go around in their spaceships and find these things all over the place. To consider that question, let me show you a picture. Here's a picture of a star. This is the star Sirius. It's the brightest. It's a blow-up, obviously, of a photograph plus a little photoshopped arrow. That's not a celestial object. Yeah, so this is a blow-up of a photograph of the star Sirius. Sirius is the brightest star in the sky, easily visible with the naked eye. In fact, as I say, the brightest star. It's one of the closest stars. It's a little bit brighter than the sun intrinsically, but you know, it's 10 light years away or so. And let me comment on a couple features of this picture. First of all, you can see the star covers a fair amount of area on this blown up picture, but that has nothing to do with the actual size or shape of the star itself. It's not like it's a big round ball with spikes coming off it. That's not what's happening. In fact, if you had perfect optics and perfect vision, this star would be a point basically so small you couldn't resolve it right in the middle here. That's the physical extent of the star at this scale is something like this. And you wouldn't be able to see it at all. The reason it's extended is for two reasons. First of all, the atmosphere distorts. This was a ground-based picture. The atmosphere distorts how you see the star. And in particular, it's like looking up from the bottom of a swimming pool. There's distortion in the atmosphere, and it makes the star seem to jump around. And so if you take a long photographic exposure of something, the star has been jumping around during the exposure, and it smears out the image. Plus, also, the optics of the telescope aren't perfect. And these spiky things here are due to the optics of the telescope. This sort of, there are all these spikes, and that has to do with how one of the mirrors of the telescope is held up. And so the combination of optics and atmosphere sort of spreads out the light by a whole bunch. This is always the case, even when you're doing observations from space. Now, the little arrow here is pointing at a little bump off in the side, which you might not have thought anything more of than you did about these spikes. But in fact, that's not a property of optics. There's actually something there. That's an object in orbit around Sirius.